Two bikes 24 meters apart are approaching each other at a constant speed. One bike is traveling at twice the speed of the other. If they pass each other in 4.3 seconds, how fast are they going? I'm going to write my givens, and then I've got givens for both bike 1 and bike 2. So bike 1, I'm going to say, starts at the origin, and bike 2 is 24 meters away from bike 1. So it's either located at negative 24 or positive 24. I'm going to say positive 24. D1 is where they pass each other, and we don't know that. V0 and V1 are the same because it says in the problem that bike 1 and bike 2 are both traveling at constant speeds. Bike 1 is traveling one speed and bike 2 is traveling another speed. One of the two is twice as big as the other. I'm going to say bike 1 speed is V and bike 2 speed is V2. And I'm going to say that bike 2 speed is 2V. I'm going to define it in terms of bike 1 speed, but I also need to make it negative, because it's 24 meters away from bike 1 at 24 meters. So it has to travel in the negative direction in order to cross the path of bike 1. Of course, acceleration is 0 because the velocity is constant, and then the time is 4.3 seconds. Okay, the unknown, we're looking for V and V2. Our equation, we're going to look at our card here, and I see that my first one works. I'm going to use D1 equals D0 plus V times T. This third term is 0 because A is 0. V is not V0 because it's constant, so it's just V. Alright, we're going to define the relationship in terms of bike 1 and bike 2. So bike 1 is at D1 equals 0 meters plus V times 4.3 seconds. And V2 for bike 2 is D1 equals 24 meters minus 2V times 4.3 seconds. Okay. So when we solve for this, we've got D1 equals V times 4.3 seconds, and D1 equals 24 meters minus 2 times 4.3 is 8.6. Okay. Now, we can set these equal to each other because when D1 of bike 1 and D1 of bike 2 are the same, the bikes cross. Therefore, V times 4.3 seconds equals 24 meters minus V times 8.6 seconds. If we add V times 8.6 seconds to both sides, we can move this to the other side. And we end up with V times 12.9 seconds equals 24 meters. And I'm going to divide both sides by 12.9, and I end up with V is equal to 1.86 meters per second. And V2, which is equal to minus 2V, is going to be equal to minus 3.72 meters per second. If we graph this on a displacement versus time graph, velocity versus time graph, and acceleration, we're going to have two plots. One is bike 1. Bike 1 starts at 0 and travels with constant velocity toward bike 2, 24. And here's 24. Bike 2 starts at 24, and it goes down with a twice the speed or twice the slope. And they cross paths right here. So we could solve for D also, where they cross paths. The velocity of bike 1 is constant, and the velocity of bike 2 is constant. One's negative, one's positive, and the acceleration of both is 0. This is a system of equations.